Hi guys. So in this project, we will be building a deep learning model that is trained on text data set to highlight which class of a video ad the video ad belongs to, which basically means that we have some video ads with us and I have taken the transcriptions from them, right? And I have my text data in it now. So through that, I will be able to train a deep learning model to see which category this video ad belongs to. Is this ad for travel, for food, for maybe some kind of entertainment, right? So we are going to do that here. We will then prepare our very own website that will be built using the Django framework and host it on Google Cloud. Right. So let's get started. Now I'm going to go through the contents of the project, which includes the introduction, right? What exactly are we going to do in this project? Maybe go a little deep in it. Then we will talk about the model and how we're going to build the model, creating our Django project, and lastly, hosting on Google Cloud. So in this project, as we talked about, we will be working on a text dataset which holds transcriptions for video of different ads. We will process or I would say we will pre-process the data into a more usable format and train our deep learning LSTM model. So this model is based on a neural net architecture and provides a very high performance on sequence-based dataset as it has the feedback structure helping the model remember the sequence of data input and the changes that are happening or to the weights, to the bias, right? Then we create a Django project which will become our base website, or I would say become the website that we are gonna host on Google Cloud. So building the model, which is the LSTM model. Now, LSTM networks were designed specifically to overcome the long-term dependency problem faced by RNNs due to the vanishing gradient problem. So LSTMs had feedback connections, right, which makes them different from more traditional feed-forward neural networks. This property enables LSTMs to provide entire sequence of data or that sequence of data can be time series or text data, right, converted into numerical one, right, without treating each point in the sequence independently, but rather retaining useful information about previous data in the sequence to help with the processing of new data points, right. So this might not have been cleared through this, but in the later videos, I will explain the structure of LSTM and how exactly or I would say, how exactly is it able to retain that information, right? Which the RNNs are not able to. So creating the Django project. Now Django is a free and open source web application framework written in Python. It includes advanced functionalities like authentication support, management and admin panels, contact forms, file upload support, and more. In other words, if you were creating a website from scratch, you would need to develop these components by yourself. But by using this framework instead, the components are actually already built. You just need to configure them properly to match your site. So basically, these functionalities are already built in the form of classes or functions, right? And you just need to import them or you just need to create the objects for these classes to have this functionality on your website. Now, lastly, hosting on Google Cloud. So this is the last stage or step in the process of building the project where we will host the newly made website. Okay, this is a little misleading. We will be making the website using the Django platform, but we will be hosting the website through Google Cloud, right? We will be using the Google App Engine for hosting the website and understand how exactly the virtual servers and the cloud system works. With this completed, we would be able to access our website and run our model from anywhere across the internet. So let's now jump into the first part, that is developing our model, right? Developing and training our model. So see you in the next video. Hi guys. Now this is the first part of the project where we will be building an NLP model, right? And through that we will be building our deep learning model, which we are going to train on our video ads category dataset. So first we will be understanding about the packages or libraries that we will be using, right? I can see that I have imported pandas, NLTK, array, strings, then some other sub packages through NLTK, then the matplotlib library, right? But before moving forward with this, let's first understand the first code block, right? Where I'm importing the drive from the google.collab. So the thing is, your collaboratory is not actually connected to your drive, where the collaboratory is able to access any file or subfolder inside your drive. So to get the access for drive through your Google Collaboratory, you have to mount the drive onto Google Collaboratory. For that, we have written this code here. Okay. Then we have our importing of packages, right? Now we have the NLTK library. Let's talk about that first. So NLTK is a standard Python library that provides a set of diverse algorithms for different NLP methodologies. It is one of the most used libraries for NLP and computational linguistics, right? The process of cleaning unstructured text data so that it can be used to predict, analyze, or extract information can be done through the NLTK library. We know that the real world text data is actually unstructured and inconsistent. So you need to clean that data, you need to, pre-process the data, which becomes a necessary step when working with text data. And so for that, NLTK provides you with a lot of functionalities and different classes which you can use and pre-process your data according to the data set, the situation, or the type of model that you want to build, right? Now, yeah, so you can even see here that we have importing the stop words from corpus. Now, stop words is a list of words which might be necessary when structuring our sentence, but is not necessary because when we are, you know, training our model from the text data, because these words do not provide much information to the model. So in a way, they are pretty much useless when training the model, right? So we remove those stop words from our data set. Then we have, okay, so coming back to the first that I imported was the pandas library. Now pandas library is like a, a data structure library which holds the capacity to maintain, to manipulate, to store different kinds of data, be it a relational data or be it a time series, right? So it has the power to store these data and it has the power to even manipulate, make changes in them, merge them, extract things from them, right? So this is again is a very important library to use whenever we are working with data sets, right? Then I have the array library and the string library. Both are to be used in our project for string manipulations and string handling only. Though array library has other functionalities too. Okay. Then we have the tokenize. Okay, so I have imported word tokenize and word net lemmatizer. Right. Now, as I talked about before, there are some methods that we use to clean and then pre-process the data, right? That is, we feature engineer the data to get variables, or I would say input variables, so that I can feed them into my model. Now, the first thing is to understand about tokenization, then we would come to lemmatization, right? Now, for now, I'm just going to tell you that we are using this function right here, this function right here. Okay, these are most probably classes, not functions. So we create the object and then use the functions that they have, and we import them through the nltk.tokenize and nltk.stem.wordnet. Then we have the matplotlib library, again a library used for creating or embedding graphs in your collaboratory or Jupyter, whatever, right? Or even basically on Python. So you embed your graphs to see or extract key information from your data. Now we are importing the data. So that's the first step. So I'm using the read CSV function, right? And I'm passing the path where my data is present. Then using the head function on my vdata variable, that is data frame right here, right? Then we have the parameter 10. So it is showing me the first 10 data points from my data set. You can see that there's an unnamed column, there's a video ID, then there's a title, description, and category. And the category you can see here is travel, right? So what it is about is that there's a title for this ad, then whatever is said in this ad is the uh, it's about the description, or it's about either it's the transcription, or if a separate description was given for the ad, right? Then we have the category right here. Okay, and you can see that the data does not only contain one language, right? You can see that here. Okay. Okay, yeah. So the first thing I'm doing is dropping the unnamed column, because again this is pretty useless. I don't want to have anything right here. Then I'm looking for null values in my data set. So that is done with the help of isNull and dot sum functions, right? So isNull and dot sum functions are two separate functions where the isNull function is providing me with a true or false, right, as its output. So what happens is that this goes row by row, and for each row where it finds a null value, it would tell me that it would return me true, else it would return me false. So what sum is doing is that it is taking the sum of all the true values that it was able to get from the isNull. So you can see that in my description, I have 334 true values because there are 334 null values here, and the sum is just taking the number of time true has occurred, right? So then we're just taking the shape, right? So my data, when I hadn't removed any null value, had 10,333 rows and 4 columns in it. Okay. After removing my null values, I have, okay, 9999 over 9,000 rows and 4 columns. Okay. Now to drop the null values, I'm using the drop any function, and I'm giving the parameter how is equal to any, which means that if a row has any null value in it, remove the whole row. Okay, so that is what this means. Then, okay, you have to uncomment this out, right? You have to uncomment out this, and you have to also run this cell block, because you might not have the stop words already present in your environment, Google Collaborative environment, and you might not have the WordNet too. So just download this, or else you would get error in the later parts of the code, right? So now you can see that I'm importing my stop words here. Okay, I've already imported these stop words, but I'm getting a set for my stop words here. And you can see that we are using the words, and I'm passing English in it, right? So this, this actually gives you a perspective of maybe the stop words have other, stop words too. Basically, we have different kinds of languages, like we have English, Hindi, we have Sanskrit, we have German, we have Spanish, and there are a lot of languages, right? And then if there's stop words, in English, then that means there are going to be stop words in other languages too, right? In Hindi, maybe Spanish, German, French. So it has stored all of these stop words in all of the languages, and you can call out language specific stop words too. So I'm just taking the result in a set so that I have unique words in my stop words, right? Then what I've done is just created a list which I thought might be useful, because these stop words also do not these words also do not provide much information, or is what I thought. So I've also added them in my stop word list. Right, so actually in sets you can either use a union or intersection, right? So I used a union to get all the unique words for the stop words for me. Then I just implicitly typecast it into list, right? And I stored it in the stop words variable. Now the next thing is the pre-process function, right? So as I told you, text data is unstructured, and at most part it is inconsistent too. So you need to have some kind of function to clean your data before you move forward with feature engineering or any other thing for that matter. Now the pre-process function is taking the input text, which is just a sentence, right? That is just a sentence. and then it is lowering, basically lowercasing each and every word in my sentence using the dot lower function. Then I'm removing tags, different kinds of tags. Then I'm removing special characters that can be at the rate, hashtag, something else, right? Maybe double slashes and all, right? So that is done with the help of sub function, which is substitution. So in the first parameter, we provide a regex expression. So regex expressions are like rules which the functions uh, look out for when they're moving through text to see if the text is actually conforming to the rules or not, which we have specified right here. If it is, then good. If it is not, then you remove that particular part of the string with the second parameter, whatever you have put, and then return back the string. So that is happening here in the remove tag, that is happening here in the special characters removal. Then once this has also, done and finished, then the text data I have is split into words. So let's say that I had the string which is it is hot today, right? So I would get a list in my text variable now, which would have it is hot today, right? So I would get a list like this. So I convert a list from a string, right? Then I'm removing stop words. So I'm moving through each word that I got from my split function, right, in the above part. And I'm looking for each word and seeing if it is inside the stop word or not. If it is not, then you can return that back. If it is, then remove that. So I'm removing stop words here. Then I'm even removing those sentences. Okay, so I'm also removing those letters where the length of the letter is less than 3, right? Basically, that means that words like was, is, a, the, all of them would be removed too. Then lastly, I am limitizing my words, right? I'm limitizing my words. And then the function is finished where I'm returning the splitted sentence that was, a list of words. So I'm joining those words back to create a string and returning that string right here. Right. So okay, this was just to reset index because the index was kind of jumbled. Okay, and yeah, so then what I'm doing is I'm taking the first 5,000, right? I've taken the first 5,000 data points from my data set for both the title and description because these are the important bits that are required for me, right? Okay, yeah. So the thing is that I also shuffled my data, right? So to shuffle my data, I've used the sample and the fraction of data that I should shuffle. Then I have the reset index so that my index is, reset after the jumble. So you can see that the frac keyword argument specifies the fraction of rows to return in the random sample, and specifying drop is equal to true prevents reset index from creating a column containing the old index entries, right? So that is that. Even here you can see that in my first we are talking about gringos eat Mexican snack, esquitos and chipped churros. And then the second is Toyota production documentary, Toyota dash dash dash. But in the above part, we could see that the first was traveling through Northeast India. The second was how do I travel so much? How do I earn money and whatever. Okay, so this was for that. Then what I'm doing is label encoding the classes. Now I have my docs class. Okay, so I'm creating a new column inside my docs data frame, right? Which is taking the data category here, right? And you can see that using the value counts function. So what value counts function does is that let's say that there's some particular values that are reoccurring again and again in your column. So it would tell you that along with those particular values, how much each one of them has occurred in your column. So the manufacturing, you can see that 1, 2, 3, 4, 5, 6. There are six uh, classes, and in these six classes, manufacturing has occurred 866 times. Then science and technology has occurred 849 times. Like, so that is that. And then what I'm doing is encoding my classes, right, using the label encoder. So you can see that my classes, which were strings before, is now numerical values right here. So for that, what we have to do is we have to call the label encoder class, right? Then use the fit function on the particular column we want to label encode, and then we transform the data so that my string data is now converted into numerical ones. And I have again, just inserted that in my docs column classes, sorry, classes, yeah, column, that is the classes. And then using the head function, you can see that the first five data points are shown to me, which is the like default value in the head if we don't pass any arguments, right? So using the again the object, if I write dot classes underscore, I get the all the classes that the label encoder was able to understand from. So you can even validate if it has done a correct, and if I've done the good job or not. You can see there's 1, 2, 3, 4, 5, and 6. So right. So in the order of index, these classes are defined. So at the zeroth index, zero class is present. So that is art and music is the zeroth class. Then the first class one is for food, two for history, and so on. Right. So that is there. Okay. So let's move on to the. Okay. This is the TF IDF part. Okay. So I would be, explaining in detail what TF IDF is and why it is so important. But that would be in the next video because this is a very heavy and very important topic to understand. Right. So once this is completed, we would move forward to the model, creating our model and training our model, which you can even see here, right? So see you in the next video. Hi guys. So in this video, we're going to start with the TF IDF vectorization, right? And I'm going to talk about what this is, why we are using this, and how this can help us to create a feature that we can input in the model so that it is able to train and classify the video ads for us. Okay. So this is a very important part of the project because this is where we are taking our clean data and creating features through that clean data. Now, I talked about processes like tokenization and lematizations, which I didn't explain in the last video. So I'm going to start with that only. Now, the process of breaking down the text data into individual words or individual tokens is known as tokenization. Is the foremost step in text analysis, right? When we take a text data and split it into individual words, it is known as word tokenizations. So when I talk about tokens, it can be words, right? In your sentence, let's say that this is the sentence that I have, right? So we have the token. The tokens would be vectorizing text features using TF dash IDF. Okay. So individual tokens can be words, can be sentences. So let's say that I have text data that is this, right? And I'm going to split this paragraph on the basis of new line. So this will be my one sentence. So I will call this as one sentence token, then this will be the second one, then this will be third one, and so on, right? So tokens can be either words, either sentences, or even characters, right? So next is that we usually, for word tokenization, or what we use is a word underscore tokenize function that is present inside our NLTK library. And I think I've even, uh, yeah, here you can see that from the tokenize, I'm importing the word tokenize function. Then the next thing, or I would say the next process, which can be an alternative to your word tokenization, is lemmatization. So lemmatization is the process of grouping together the inflected forms of a word so they can be analyzed as a single item identified by the word's lemma. Basically, what happens here is that we are also again trying to tokenize the words, in the sense that we are trying to split our words from the sentences to get unique words out of them. But not only that, we are converting words like was, been, okay, not been, was, will, into the into a particular form of the word, right? We have the past tense, we have the present tense, we have the future tense of words, right? Then we have other complex uh, uh, tense to regress all of those terms into one term that would be like in the present tense or in the just past tense. We use the lemmatization. Okay, so moving forward, what is TF-IDF, which I was, uh, emphasizing so much on about why this is so important at all. So TF-IDF is term frequency inverse document frequency, right? That is the full form for that, which is a statistical measure that evaluates how relevant a word is to a document in a collection of documents. Right. So this is done by multiplying two metrics. So TF and IDF are two separate. So TF-IDF was invented for document search and information retrieval. It works by increasing the proportionally to the number of times a word appears in the document, but is offset by the number of documents that contains the particular word. So in other words, that let's say common words in every document such as this, what, if, is, and some other words that you can even see in the stop word list will rank low even though they may appear many times, right? Since they don't mean much in the document in particular, and the offset also decreases their value so that we only find the relevant words or those words from a document which explain what the said document is talking about, right? Now let's declare. Okay, so let's talk about the declared terms, right? I talked about two metrics, that is term frequency and IDF, which is inverse document frequency. So term frequency of word in a document is a raw count of instances a word appears in the document. So basically, let's say I have this as my document, right? Then vectorizing comes once, text comes once, feature each and every token comes once. So I would say that the term frequency of vectorizing is 1 in my document. Then we talk about the inverse document frequency, right? Then we talk about that. Now the thing is, inverse document frequency of a word is actually calculated across a set of documents. This means that how common or rare a word is in the entire document set. The closer it is to zero, the more common a word is, right? This metric can be calculated by taking the total number of documents we have, dividing it by the number of documents that contains a word, and calculating the logarithm for that. Basically, what is happening here is that we are taking the number of documents that we have. Let's say that I have 50 documents with me. Okay, I have 50 documents with me, and inside that I am searching for the word rel okay relevant. Okay, so I'm looking for this particular word right here. I am able to find that this word which is relevant, right, it is, I'm able to find this in, okay, I'm able to find this in 15 documents, right? 15 documents. When I talk about documents, it is basically text data, right? We have some kind of text data. So in 50 text data, the word relevant I was able to find in 15 text data, right? 15 unique text data. And the number of times the relevant word has occurred in 15 documents is 455, right? Let's say that. Okay, this means that a lot of in even one document, a lot of relevant words are there. But just for example, take this. So how do we, take the IDF is that we divide 50 by 455 and then take the log of it, right? So I get a very small value right here, right? I get a very small value here, and then what happens is that we multiply our term frequency with the inverse document frequency, right? We do that, and the higher the score is, the more relevant that word would be in the particular document. Because let's say that there's another word which is purpose, right? We have this, and this has come in 10 documents and has occurred 40 times only, right? So the log for this value would be greater than the log for this value right here. And this would tell me that this is a rare word that is coming inside my document, which basically means that this is somewhat a relevant word inside the documents, because first, it is rare. Second, when we talk about words which are common or rare, we only use rare words when we want to, signify something in our document. Or that is how TF-IDF was, I would say, initialized, that people would write rare words in their documents only when they want to emphasize on something, which means that the document itself wants to emphasize on those particular words, which is in a way kind of right too, right? So this is what is happening in TF-IDF. And then we have, okay, so I've just imported the TF-IDF vectorizer from the feature extraction.txt of the sklearn, that is scikit. Then making an object for that, right? So I've made an object for title and for description differently, and you could just use the same one for both. But the thing is, then all the information would be stored in a single variable, which might create problems later on. Okay, now we have this, and we have sublinear. Okay, so we have the norm, which is L2. Norm is basically normalization. We have encoding, should be in Latin 1. N-gram ranges. So n-grams are basically set of words, set of one word or set of two words, so that the vector is able to understand what word might precede another word, or what word might be relevant to another word, right? Then we also giving the option of stop words, which is telling that if I have missed some stop words that are of the English language, remove them too, right? Then I'm using the sublinear function and it is set to true. Then I have the minimum difference as 5. Then, okay, so I have my dogs. I've taken that in labels just to create a y dependent variable to take the dependent variable out separately when I'm going to use it as to train my model, right? We take in the x and the y in the train test split, right? So that is what I've done. This is my y right here. Then I'm creating the features using the fit and transform. Again, the same for the description. And now you can see that I have a feature shape of 5000, which was the number of rows I took from the text data. And then I have the number of features. I would say the vector. This is actually the length of the vector that is created by the TF-IDF vectorizer. Right? I have 1267 for my title and 2690 for my description. Now we come to the last part where we are going to talk about the building and training of the model, right? We're using LSTM right here. So I would cover this part in the next video. I'm going to talk about what Keras is, why it's useful for us, how we're going to create the LSTM model, what is how going to we train it, and lastly we're going to save the model. Okay, so see you in the next video. Okay, now moving ahead, we have imported a lot of things from Keras library. Now this is a standard, I would say, standalone Keras library that we are using. And from here you can see that I have imported dense layer, embeddings, LSTMs, right, spatial dropout for one dimensions. And then we have the sequential wrapper from our models. Then we have the tokenizer, batch sequence, and other stuff that we are going to use. Now, Keras is a neural network library, and it is an open source software library that provides a Python interface for artificial neural networks. And Keras acts as an interface for the TensorFlow library. While TensorFlow is the open source library for a number of various tasks in machine learning and deep learning, TensorFlow provides both high-level and low-level APIs, while Keras provides only high-level APIs to be used. Right. Now you can see that I have specified the maximum number of words, right? That is 10,000. Then I have the sequence length, that is 50. Then I have the embedding dimensions, which I'm going to use later on, and you will understand what these are and why we have specified them here. So I'm combining the title and description into a single sentence, right? Then with the help of the tokenizer function imported from Keras, which is specifically made for text data handling, we have given the max number of words that we should be using. So let's say my vocabulary for the text data turns out to be, let's say, 50,000. Like 50,000 is a very big number. So what happens is that we only take the unique values and the most occurred values from my vocabulary, right, to downsize the 50,000 to 10,000. Okay, so that is why we have specified that here. Then this is filter, which works like a regex expression, right, to only get the text data. Then I have the lower, which is lowercasing all the data. Now this I have done this, but this is just to show you that there are different ways that you can pre-process your data. There are different functions which will help you in pre-processing the data, and this is a way of just validating things for myself, because I might have missed something in the upper pre-processing tasks, so this might clear them out too. Then the tokenizer has a function fit on text to understand what the text data is about and to create my final feature list. Then after fit on test, we can even have the word index with us. So you can see that we found 16,060 unique tokens, which basically means there's a vocabulary for us is 16,060, right? Then yeah, moving forward, then you can see that I have the next thing, which is text to sequence. Now, what is happening here is that we are converting the text data to numerical data so that we can input that into the model, right? So we have our text data, which is converted into a vector of of 50, right? Vector of 50. And then yeah, okay, so and then we have taken the data right from here, which was fit on text, okay, which was the uh, yeah, which was actually the conjugation of both the title and the description. Then we pad the sequence. So what happens is that the text sentences are not all of the same length. Some might have 50 tokens, some might have 70 tokens, some might even go to 200 tokens. So the text to sequence data, where we are converting the text into numerical values or vectors to be exact, they might have different lengths, right? To keep all of the lengths same, we use the pad sequences, right? We take the vectors and we take the max length right here. So if a vector has more than 50, it would downplay it to 50 if the length of a vector for some text data is only 30. So it would pad it with zeros to make it of length 50, right? So this way we can do that. Now you can even see here we have the 5,000 rows, right, our data points, and we have 50 columns, which is basically telling you the length of the vector that were created right here, okay, the sequence. Then I'm hot encoding the labels too, so that I'm able to input the Y values into the LSTM model too, right? So you can see that we have 6 classes, so we have these 6 columns created here with the help of one hot encoding. Okay, so we have the okay. This was just to show you the titles that we have, and the after the conjugation we can see that this is the title right here, then we have the description right here, right? So this is how we input the data, and then now we are finally defining the LSTM model. Now the LSTM model is taking again the max number of words to, and then the embedding dimensions, and finally the length, which was 50, right? We took the sequence length to be, or vector length to be 50. So this was okay. This was why we created the max word. That was because to downsize the vocabulary, but embeddings dimension was created so that embeddings understand the dimensions for the layer, right? Then we have the spatial dropout, and then the LSTM model again taking 100 neurons with it. The dropout is again 0.2, and then the recurrent dropout is 0.22. Then we have the dense layer, which is going to extract the information that which class this data is belonging to once it's training on the data, right? And using the activation function as softmax. Now we have just compiled the model and taking the metric as accuracy. This is not the best metric to use, but it gives the it gives you a simple brief explanation of if your model is working fine or not. Right. So using the summary, model.summary, you can even see the parameters and the shapes for each of the data that would be inputted. Right. Then I have taken 10 epochs for my model and a batch size of 128. So you can see that after running the fit function, you can see that I have an accuracy of 99.5, which is very good, but that is for training. And for your validation data set, you have 95, 96. It goes to, okay, it's increasing, that it decreases a little and increases again, and it decreases in the end. So uh, in and all, we're getting 96, 95 percent accuracy for a validation, which is very good, right? And even here you can see that I've created some graphs to see how exactly our model is working. So you can see that this is my train. The loss function for this is it is decreasing, 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 then increases a little after 8. So from here I can understand that maybe in my model I should stop at 8th epoch because I'm getting the lowest loss here. Then in the training you can see that it is varying, and after 8 it increases a lot, right? So I think I could have stopped at 8 only, or I could have stopped at 6 only, right? So this is why we are creating the graphs here. And here you can see that the accuracy for training is quite reaching 1, but for testing it is again in 96 and 95. So this is pretty good. I would say this is very accurate for us, right? And then the last thing to do is saving the model and the tokenizer. So I've saved the tokenizer right here. Okay, I've saved the tokenizer right here, and I have the model right here too. But you might have noticed that rather than okay, moving forward, yeah, you can see that the feature title and feature description that I created, right, that was not used anywhere, right? You can see that this was not used anywhere, right? You can see that here too. I mean, we had the feature title, feature shape and all, but they were not actually used in the data. Actually, it was not used as data to be input into my model. You can even see here I'm taking the temp list, which is again the titles and descriptions only, and these are from the data frame. So the thing is, we created our features here too with the help of tokenizer. But if I were not to use this, then I would have just directly used my feature description and feature title for the data to be inputted into my model, right? So either you can let it stay as it is and go with tokenizer, or you can use the feature title and description. Okay, but that was just to show you that instead of tokenizing the data and creating a vector, you can even have a different kind of feature engineering done on your text data, which again can be input into your model too, right? So coming back to here, we are using the pickle and using the function dump, we have saved the tokenizer, and using the function save for my model object, we have saved the model too. So I've given just the path to where I have to save the model. And in the next video, when we start with the implementation of the Django framework to create our website, you would see that I'm mounting these models there. Right. So we have completed the first part, or I would say the first step where we were developing the model. Now our model is developed, trained, right, and we can now use the model. Now moving forward, we would talk about the Django platform, or I would say the Django framework, how we are going to build the website, right? So see you in the next video. Hi guys. So in this video, we're going to start with the Django platform and start building our website. Now, Django is a free and open source web application framework written in Python. And a framework is nothing more than a collection of modules that might make development process for developers easier. Okay. The framework is actually grouped together. I would say that framework is actually accumulation of a lot of functions or functionalities that allows you to create your application or website faster as compared to, let's say, writing everything from scratch. So this is how website, even simpler ones designed by a single person, can still include advanced functionalities like authentication support, management, contact form, basically submission of data from front end, file upload support, right, and more. Now, Django provides a lot of functionalities. It helps you by already providing you an existing code base onto which you can write more code or append more code to add on functionalities that you require particularly, right? Now, Django has a model template views architectural system that keeps in mind the requirements of front-end and database management for a developer. We will see what this architecture means and what makes things easier for a developer when we say that Django, provides a lot of functionalities to the developer. Okay. Moving forward, let's first see how to instantiate a Django project. Right. Now I've written some steps that you can follow while you are creating or instantiating or just configuring the Django project. Now I'm going to go forward with two situations. One where you're going to create your own Django project. You don't want to use the code base that I'm going to provide you. And the second is where you will just try to configure the code base that I am providing you. Okay. Now, with the first situation, the thing is you have to create a virtual environment for your project. So just create a directory where you're going to store or we're going to create the Django project, right? And for that directory, create a virtual environment. So if you're using PyCharm like me, right? If you're using an IDE like PyCharm, then you can see this is my, this is my directory, project directory inside where my code is set up. So in that directory, what I've done is just went to settings, right? If you're using PyCharm, then a pop-up will open. Then inside settings, I have the project, then project interpreter. Click on add in the settings button, and then another pop-up will open, and you can type in the environment name and where it has to be stored. Then your base interpreter. For me, I'm using Python 3.7.6, right? If you have different versions of Python installed and they are configured properly, right, like the path is defined in the system variables, then it would show here that you have different Python versions, right? I have 2.72, I have 3.8.32, I have 3.62, okay, I have 3.10.2, right? So I have a lot of Python versions, but yeah. So you can even select which one you want to use, then click on OK. But since I've already created the environment for me, and you can also see that the environment location is not empty because that is where my existing environment is set up. So it's not, letting me create one. Now, and then just click on apply and click on OK. So once your virtual environment is set up, the next thing to do would be install Django version, any version basically. So just install pip install Django 3.2, any version if you want 3.4, 0.4, 0.0, right? You can do that. Once this has also completed, write this particular command, which is talking about Django admin start project name of the project. Now I wrote name of the project as my site. So once you run this command, right, Django admin start project name of the project, then a directory will be instantiated and created here, inside which this another directory will be shown here in the my site part, right? And you can see there are some files like settings.py, vsgi, asgi, right? So with this we can configure our Django project exactly, like we can make changes in these files so that we have we can control how Django will be, I would say, how Django would be connecting to other applications, how Django would be handling itself, if there is a cache system or not, right? So all of that is done through here. Then once you have also created your project, then what you have to do is take the requirements.txt file from my code and put that inside the your project directory here inside this, right? Then run the command pip install -r requirements.txt. So this is going to, okay, this is going to install all the dependencies or the packages that are required by your project to run smoothly, right? It would do that. Then, okay, so then, yeah. So in your my site directory right here, you can run the next command, which is python manage.py start app, name of the app. So you can see another directory here, right, which is polls. So this is my app, and you can see that apps have different py files as compared to here. So apps are created to add on additional functionalities in your project, right? If you want to have something which is loading the model, if you want to have certain application having PPTs embedded in your website, then for additional functionalities you have to create your own apps. So that is what I've done for my project. Then the next thing is to set up the settings.py file, which is initializing or changing some variables so that the application is working as we want it to, right? Then, okay, so I'm going to skip this part right here and shift this part into either the in this video later on or in the next video, because first you have to run this command too, which is python manage.py migrate. Now, migrate is basically a function that is called when you want to instantiate the tables that you have created in Django, that these tables have to be configured inside your database systems too. If you're using SQLite 3, then that is pre-configured with Django only, so you don't have to do much. You have to just run the migrate command. But let's say that you're using external applications like MySQL or Postgres, right? So then you have to make some changes in settings.py file too. But after that, you can just run the migrate command, and all the tables that you have created inside Django will be instantiated in your database too, right? So this is the part where if you want to create your own Django project, if you want to just use the existing code base, then just create a virtual environment, then directly go to this, right, cd into the my site directory where the requirements.txt file is present. Run this command. Once you have run this command, directly run this command python manage.py migrate, so all the tables are created. So what happens is that Django also provides you with some of its own tables so that it is handling things internally, right? So those are also created with migrate.py, right? So that is all that you have to do if you were to use the existing code base. Then this is the last command which we will run after we have properly configured and set up the project. Now moving to the settings.py file, right? Now you can see that there are a lot of variables that are created, right? You can see that throughout the file there are a lot of variables that are created which are stored with some values. Now the first variable which is important to know about is the secret key. That secret key is unique to each project that has been created through Django, and with the help of secret key you can access or work with a lot of things. So this is, again, as the name suggests, kept or is to be, a secret from other people or other applications too. So what I've done is that I have imported the key from somewhere, and I'm going to explain what this is doing in just a minute. But before that, let's move on to other variables that we have right in the settings.py file. We have the debug. So debug is equal to true means that all the errors that you might come across will be showcased on the page, right? You would be seeing the trace back of the error, where it is happening, why, right? But if it is false, it would just give you an internal error or a status code telling you that some kind of error has occurred. So this has to be set to false when you are into production, basically when you have hosted your site. Then we have the allowed host, right? We have the allowed host right here. And this is the local host, which means that your application can be connected to your local server on your machine. And through that, you would be able to run this code and see how exactly it is performing. Then we have our installed apps. So you can see that these are the apps that were created by Django itself because they, provide you with additional functionalities which are set up inside here in these apps. So you have the admin app for management. Then we have the authentication to authenticate users if you want to do that. You don't have to write code from scratch. You can directly use the auth app and its functions, whatever they have created in that. Then we also have for sessions and other for messages too, right? Then this is the one we have created by ourselves because we wanted to have certain functionalities which Django doesn't provide, right? So you have those for yourself right here. And you can even see that we have middleware set up here, right? We have middlewares, and these are also handled by Django. You can see there's a security middleware, a sessions middleware, a CSRF view middleware, which is used for forms, right? We have authentication middleware too, and XFrame optional middleware too. Then we have the templates, right? So I talked about, model template views, architectural system briefly. So templates is basically nothing but your front end part which is served to the user. So when you hit a particular URL, the pages that is showcased to the user is what we call templates. Then we have the database too and the catch system too. So in the databases, we are using the SQLite 3 which comes along with Django, right? But if you want to use an external database like MySQL or Postgres, then you would have to configure that here by typing in the user, the password, the port on which connection would be established and all. So that is done in the database dictionary which we have created. And we have the catch system here. So CAD system is basically, I'll talk about CAD system later, but the thing is, even to use CAD system, you have to configure that in the settings.py file. So I've used a default version where we're taking the low mem cache, right, as a backend, and location as unique snowflake, which is basically a unique, uh, something unique that can define my cache, okay, or the place where the cache things will be stored. So that is that. So these are the important bits that you should know about, or if you want to, go in detail about each and everything, then you can go through the document that Django provides, right, through this here. or you can even go through this here if you want to see the list of all the variables that are used to configure your Django project. Now coming back to this part, right? So what I've done here, you can see that I'm getting the Django key from somewhere, right? So the thing is, all the secret part, I would say all the secret information that you don't want to showcase to your user or to anybody is called through a separate file. So I've created a .env, right? Here you can see that a Django key is established here. So what I've done is I've created a key pair where the key is named Django key and the value is my secret key. So what I'm doing is I'm with the help of .env load.env function, I'm loading all the information in my .env variable, sorry, .env file into my system variables, and through the load.env I'm calling the data from my system variables into my project, right? So using the os.environment.get, get is to get key, and you input the key here, then you get the value for this particular key here, and that is inserted into your secret key. So with the help of this, what happens is that even if somebody has the access to your code, you can, still keep your credentials or important information away from the person who might have hacked your code. Now, you might be thinking that even if somebody gets the code, he would be able to get the .env file, right? So the thing is, once you run the project for once, all of the information from .env is sent to the system variables. Then you can delete the .env file, and the project will call out the information from system variables directly, right? So that way, nobody's going to get the credentials or the important bits of information that you have in your code, even if they get the access to the code, right? Now, moving forward, okay. So I talked about the model template views architectural system, right? So we will talk about this in detail in the later video, where I'm going to talk about how do you set up or how do you write code in your backend to handle things, what is happening in the front end, how are they connected, what is models, right? All of this information would be, explained in the next video, and then we will run our project to see if the website that we have created using Django framework is working properly or not. So see you in the next video. Hi guys. Now in this video, the first thing we are going to talk about is what is model, what is views, and what is templates. Then we are going to talk about how each of them are interconnected to each other and how is the Django project exactly working under the hood. Lastly, we're going to configure, okay, we already configured, but we're going to run the project and see if the project or the website is working as we want it to. So you can see I have opened the views. Now views are actually specified in your apps, right? Because we are building additional functionalities onto the website, they're defined in the apps and they have to be, the code has to be written in the apps only. Then we have the models right here again in the apps and the templates. So you can see that templates only stores the HTML file or the CSS stuff, right? Because that is what is served to the user. Then, okay. So the first thing I'm going to talk about is models. You can see that in models.py, it is loading models from django.db, importing it, and you can create your models here. Now, models are nothing but database objects that you write the code for here, and then you tell Django that these are the tables that I want to have, and now you create these tables in my databases and handle these tables in my databases. Okay, so you write your code here, things get instantiated in the database you are using, be it the SQLite 3 or the external ones, right? And then through here you can even make changes. You don't have to open a new application there. You can make changes, you can write constraints in it, or you can delete the tables if you want to. All of that can be done through Django too, right? So this is how a simple person working on Django project can handle the database uh, management things, or he can also work with the front end. So let's talk about front end too. Now the index.html page that I've created, as you can see, has some CSS in it. What the hell? Right. Okay. I think my laptop lagged a little. And yeah, so I have the CSS here. Okay. I have the CSS right here. And then, okay, and then I have the form. So I've created a form, and in the form, I'm taking the input, and in the form, I'm taking, okay, so I'm taking the input as title, I'm taking the input as description, right? So both of these are text data that I have. And as we know, we are going to take this title and description, create one specific text data for it, convert that into, get our features from it, and finally put that in the model. Now we have the text data, we have the description and title. So once you click on submit, right? Once you click on submit, then all of that data is sent back to the backend. Okay. So yeah, in the backend, that is our views. Now you create functions in the backend, right? You create functions in the backend where you create functions in the backend, and right here, yeah, this is the first function handler, which is taking a parameter request. And what is happening here is that you can even see we are returning something that is the output of the render function. So this is how we have mapped something from the front end to the back end. What happens is that you call this function handler. It understands that in the render function, I have to render the HTML page, this specific HTML page. Then you would, yeah, then you would see that once this function is called, this HTML page is rendered and showed to the user. Then the user maybe input some data, click on submit. Then that data is coming to the backend here. See, I'm storing that data here, right? And I'm sending that data to my predict function. So basically we are manipulating the data, getting the results in the inside the function, and finally sending back the result. So the result or any information that is to be sent from backend to the front end is sent through a dictionary, right? Which is called context. So we are sending data back from the backend to front end through context, where I'm writing something key and giving the my result that value for the response key, right? So this is how backend and frontend, or I would say the views and template architecture system is working. So we have excluded models right now because we are not storing any data, or we haven't created any models or tables yet, right? So let's move forward to the predict function. Yeah, so this is the predict function where what I need is to create my one text data, right, from appending the title and description. Then I'm using the text to sequence to create the vector for the data, right, getting the text data to be converted into numerical ones. Then I'm loading the model here, right? I'm loading the model here, and then using the predict function for it, I'm getting the class for my predicted value and returning the class. So it returns a array of 0, right, of one element, which would be 0, 1, 2, 3, 4, 5, right, because we have 6 classes. And that is that, right? So I've already also print. Okay, so I've also taken a label reverse function, which is taking in my array, right, value of the array, which would be 0, 1 or 0 to 5, and then I'm reversing it to get my class. That what exactly is the class? Since 0 is associated with I think artist, right? 1 was for food and all. So there we get in the FINA we get a string that would say, yeah, you can even see that it is having a string which would be either artist, travel, or food, right, or any of the other class. So that is what I'm sending in my context here. The last thing I'm going to talk about is sustain.py. This is a file I created so that I can have cat system working on my project. So I'm calling out the cache, importing it, and I'm also importing pickle so that I'm able to load my any object that I want to, that I want to store in my cache system. So we create a cache key, right? And using the cache key we get the particular object, and if we don't have any cache key created, or if we don't have any particular object created, as you can see here, we set the model, or we set the object into a particular variable, and then call and then set that particular variable and the data it holds into the cache. So you can see that I'm using the load function of the pickle to load my tokenizer into the tokenizer variable here. Then I'm storing the tokenizer inside my cache, right? So it takes a parameter that is key and then the object itself. So the next time what happens is that, let's say for the first time this project is running, then it would tell that there's no cache. I have to, actually there's cache, but there's nothing in the cache, and I have to instantiate a tokenizer. Then here the tokenizer is loaded, then the tokenizer is sent into the cache, and the cache is set, and the cache key is set and mapped to the object. Lastly, when you refresh or reload or maybe rerun the project, then the cache that was already set up would see that a tokenizer is already present, which has a key. Then I just have to uh, get the object which is mapped with the key. So even after reloading again and again, your model won't be loaded again and again into the tokenizer variable. It would simply be called from the cache. So this makes your site a little faster, and it helps in reducing the refresh time it takes for your site, right? So that is for your cache system. So finally, let's run our project and see if it is working properly or not, right? So the command is python manage.py run server. So hit enter. Now, Django in itself tries to have a system check which uh, instantiates a set of checks inside your code to see if it is working properly or not, if it is configured properly or not. And once it is able to see that yeah, the code is okay, then it would provide you with the local host URL, right? It would provide you with the local host URL that you can see here. And Django by default works on 8000 port. You can override it, but uh, I don't see any reason to override it right now, right? So I've let it stay as 8000. So once you click on this link here, or if you would just copy, okay, you can't simply copy. Okay, once you copy this, this is taking like so much time just to open a link. Just open this link, just open the browser itself and type in the link. Right, so you can see that no page is found when we open the link, right? That is because we haven't specified for this link what uh, what function is to be run. So even here you can see that I have my functions created, but there's no call for the function. So for that, we go to urls.py, and there we specify at what path which function has to be called. So you can see that at path home, we have to call the handler function. So going back to the browser, if I type in /home and hit enter, you can see that I'm getting the page that I want to have, and it is showing me that there's an error, which is basically because we haven't typed in any data right now. So if I uh, type in the data, right? And if I click on submit, you can see that the model is now loaded, the website is working, and then it would provide me with the category for this ad. I'm just taking, okay, so you can see that the category was food. Again, you could see that we were talking about chip churros, right? It is all, and then we are also talking about Mexican snack. So yeah, so our website is working fine. We are able to load the model too, and with this we have completed the second part, right? That was building the website using Django framework, and then we would now move forward with the third part, and also which is the last part, where we are going to host this website onto AWS, sorry, onto Google Cloud. Yeah, and I do really like AWS, but yeah, we're going to go forward with Google Cloud in this project. Hi guys. So in this video, we're going to start with how to set up a virtual machine in your Google Cloud platform and how to configure that particular VM, and if you have to make some other changes on your platform so that we can host our website onto this particular VM, right? So hosting the website we have developed, we will be using Google Cloud Services, which is kind of obvious from the dashboard only, and we will be using the Linux VM they provide, which are scalable computing, which have scalable computing capacity in the Google Cloud. Now the VMs that we are going to use have some of the following features, like they have pre-configured templates in the instance known as machine images that package the bits you need for your server, including stuff like operating system, additional software that you might require to run certain projects, right? Now the instance also has when we yeah so the instance also has various configurations of CPU, memory, storage, and network capacity for the particular VM, and they provide you with secure login information for your instance using key pairs. Now this is important because the thing is, we can either create a username and password, or we can create a username and SSH keys to log in into your particular VM from anywhere across the internet. So if you want to log in into your VM from your local machine, then you do need a SSH key, right? So that is for your login information. Then they provide storage volumes of different kind. There's permanent, there's temporary data storage, right, which gets deleted when you stop your instance or terminate your instance. So that depends on the user. If the user has set up the VM such that if we stop the instance, everything is deleted, or if we only terminate, then the data from the disk is deleted. Then they also provide you with a firewall that enables you to specify the protocols, ports, and source IP ranges that can reach your instance using security groups. Now, that security group is mapped into firewalls inside Google Cloud Platform, and we will be going through that because we do have to add certain rules so that our Django application is able to, connect, or better yet, the instance is able to connect to the Django application that we're going to host in it. So that is that. Then we have the static IPv4 address for dynamic cloud computing, known as elastic IP addresses. So let's start with the hosting process. Now, the first thing to do here is, yeah, actually the first thing to do here is install certain softwares, right? So the first software is Putty. So install that. Now, I am asking you to install that, but it might be that you might not want to use this. So this is a free SSH and Telnet client for Windows, which is basically opening the console of your VM in your local machine. So that can be done in Google Cloud through the connect option, which is given for your instances, and you can open in browser, or you can use another SSH client where it would ask maybe to use Putty or something else, right? So you can download that, or you can skip this one. Then install Putty Gen. Now this is important because this helps us in creating a private key file which will be used as a password when you're going to log in into your VM. So install this, and the last command is win SCP. Okay, sorry, not the command, but the software is win SCP, right? So this is the software that we are going to use to I would say transfer our files from our local machine to our virtual machine, right? So install this one too. The download options is here. Now this is for Windows basically, because Linux and Mac OS gives you option from SSH into your machine and transfer things from the console itself. Even Windows gives that, but it is a little messy and a little hard to understand. This makes things simpler for you, right? Now, once you have already downloaded all the software that I have specified, then in your Google platform, just log in into your platform, run any project. So I'm running the first project only, which was pre-instantiated when I created my ID on Google Cloud. Then in the, okay, so you might not be seeing this dashboard right here. You might be seeing the this one, right? So you might be seeing a different dashboard like this one, which has a home, recent, maybe not recent, but I am admin, billing, API services, marketplace, compute engine. You might be, this might be empty for you because you haven't instantiated any sorry VM yet, right? So I had instantiated a VM, so it is showing me the compute engine and the CPU usage for now. Then inside your compute engine, right, inside your compute engine, go to VM instances. Click on VM instances. Then you would see the page which I was on before, right? So once it has loaded, it would show you the instances that you have created. And if you haven't created, this would be pretty empty. Then click on create instance, right? Click on create instance. In that, you have the option of configuring your instance, right? So we would move, okay, right. So just name your instance anything. Okay, I'm just naming the instance video 2. Okay, you can name the instance anything. Then select the region. So I'm going to select the east. Okay, I'm going to select the Southeast Asia region. Let the zone be the default thing. Then the machine configuration, if you want to use the general purpose one, compute optimized or memory optimized. I'm going to go for with general purpose one because we are not using, or we are not created an application which requires highly optimized CPU power or requires a lot of memory to be used, right? I'm going to go forward with the EC2 series only. But with the machine type, you can see that EC2 medium has 2 vCPUs and 4 gigs of memory. Now this is a lot. We want to not use this one. I'm going to go for T2 micro, and T2 micro has 2 vCPUs and 1 GB of memory. So I'm going to go with this one. Then let things stay as it is. If you want to, have your container, if you're going to dockerize your code, then go for deploy container. Then you can see the boot disk, which is the balanced persistent disk having 10 GB size, and the image that I talked about before is the Debian Linux. Now I'm going to change this because I want to use Ubuntu. It gives you other options too, right? You can see if I click here, it is giving me Ubuntu, it is giving me Windows Server 2, it is giving me SQL Server 2 for Windows. Then there's Red Hat 2. So I'm going for Ubuntu. Then in the version, I'm going to go forward with 20.04. I'm going to keep this as balanced persistent disk, right? Or you can go forward with SSD persistent disk too. So you can go forward with that too. Actually, it's better yet go forward with this one because this one uh, increases the cost a little, but your speed of transferring files, your speed of accessing files, your speed of installing and loading things becomes a lot faster when we go from balanced to SSD persistent disk. Okay, and 10 GB is enough for us. We won't be using even half of this, but yeah, let it stay as it is. If you want to decrease that, you can do that. There's advanced configurations too if you want to go forward with that. I will not go forward with this because I don't even understand some of these what they do. But yeah, click on select. Then in the identity and API access, let it be allow default access. Okay, do not change this. Uh, do not change this settings right here. Then in the firewall, allow HTTP and HTTPS both traffics. Right. Actually, if you want, you can remove the HTTPS part, but do set the HTTP traffic, right? Then we have additional settings for our VM, right? Additional configurational part. You can see that in the start uh, we had kind of, what should I say? We had three, I think 30 US dollars. Now it had gone down to 8 and then has come back to 9.38. Right. So this is monthly estimate. So hourly that would be something like this. And Google Cloud already provides me with 22,000, actually more than 22,500 free credit, and that would be for 90 days, right? So then coming back to configurations, we have the network, let it be as it is. Unless you want to create tags for your network or you want to set a custom host name, make changes there. Then let these things be stay as default. Unless you have already created a network interface, you can let this be as default, or else what you can do is add your network interface and remove this default one. Then we have the disk. Now as I told you about, we had the boot disk, right? If you want to add a new disk or if you want to attach an existing one, you can do that from here. Then we have the security part, which is shielded VM and SSH keys. Now let them be the default values, but in the SSH part, what you have to do is click on add items and it would ask you to input an SSH key here. Now this is extremely important because this is where you're trying to create a password that would be used to log in into your VM. So what you have to do is go back into your code wherever you have set up your code. Right, you can see that my code is present here, which has the application. So here what I'm going to do is I'm going to open the CMD. Right, I'm going to open the CMD, and the CMD I'm going to run the command key gen. Okay, uh, it's SSH keygen. Sorry, SSH keygen, because we are going to create an SSH key. Right, so you can see that you have an option of writing the name of the file. Write it as, I'm going to write it as video2. It is going to ask for a passphrase, which is kind of password for your password for your SSH, right? So I'm going to keep this as empty, and see, it has created the SSH key for me. So basically we have created a password here, and you can see that I have two files here. One is a file and the other is a file of .pub. Okay, so publisher type. Now you have to open your file, publisher file, open in a notepad or any other, uh, basically you just open it where you can access the content. Once you open this, you would get an SSH-RSA and some keys, right, written in there. And yeah, so you can see that here. So the key is created, and at the last there would be a username, uh, the username or the user of the local machine would be set here. So if you don't have something here which is defining which user has created this, then you have created a wrong SSH key and you need to recreate one. Or see if your user is actually, stated in your system details. So just copy this if there's no problem in the SSH key. Just copy this and go back to the code, sorry, go back to the dashboard, click and paste here. So you can see that I pasted here and I can move forward. Then then I can just directly go and create. Okay, so I'm not going to create a new one because I already have one set up. But once you click on the create, right, once you click on the create button, it is going to take some time and it will tell you that yeah, now they have deployed your VM and you can access and use it, right, to set up your code inside that. So I'm going to go back, right, and I'm going to show you the VM that I had created using the same steps I have, showcased now. So this ad classification was created by me, and once you have also created and the VM is set up through the Google Cloud, it would give you an external IP address, right? So you have to copy this external IP address, right? You have to copy this because the next step here would be to send your data or your files from your local machine uh, to your VM. Yeah. So we're gonna start with Putigen. So click here and type in Putigen and open this. Now in the Putigen part, you have to click on load. Then you have to go to the directory where you had saved your uh, publisher SSH key that you had created, right? So you have to also input the all files because it's not going to show you then the. You can see that I already had created one and I just now created another one. So what you have to do is you have to take the file, you have to select the file and click on open. It would say that it has successfully imported foreign key. You have to click on OK. Then you have to click on save private key, click on yes, and then you have to name it. Um, right, I'm going to name this that, and I already created one here, but just to show you it to you, you can just save this because this is the file we're going to use to log in into the virtual machine through WinSCP. Okay, so as I talked about before, my WinSCP software was used to transfer files from your local machine to your virtual machine. Now, once this opens up, it would showcase you something like this, right? Showcase you something like this, which is not okay. It kind of got lag. Yeah, so new set in the new side it would show you something like this. If you are using WinSCP for the first time, if you are not, then it would show you something like it has already created a connection and you just have to refresh it to establish a new connection. But if you're using it for the first time, it would ask you to type in the host name. The port number is going to be 22 only, and then the username and the password. So keep in mind that your host name is actually the IP address, the external IP address given by Google Cloud. Your username is the username of the local machine user, right? So my was kit, as you could have seen, my was kit at the rate some numbers, right? So kit was the username there. And for you, you might also have a particular username. That is what has to be inserted here. And then in the password, click on advanced. And in the advanced section, there's going to be a lot of, yeah, there's going to be a lot of options. You have your environment, connection, SSH. Just go into authentication in SSH. Browse the private key file that we created using Putigen. Right. So once you do that, we have two of them right now. So you can just uh, click on, okay, I'm going to use this one. That is because this was not associated with the virtual machine I had created, right? This was just to show you how exactly we make a private PPK file, right? Putty private key file. So I'm going to use the previous one, which I had also associated with my VM, and I click on open. Then I can click on open here and I can click on login. So once I click on login, it's gonna reconnect or create a session. Then it's authenticating the public key, and yes, I have now connected to my VM. So on the right, okay, on the left, I have the on the left I have the local machine. Right now in the local machine, I have located where my code is present, and on the right side, I have my VM, right, which has the my site uh, files already. So if you want to transfer file, you can just drag and drop, right? You can just drag and drop and click on OK, and it would ask to overwrite or all. So I'm not going to overwrite anything, right? I'm not going to overwrite anything. But the thing is, for you, it would ask you if you want to transfer all the files or not. Then you can just click on yes, and it would do that. Then let's say that you realize you have to make some changes, right? In my site directory in the settings.py file, you could have seen that there was only local host present there, right? Now you have to add this in your code. So you can even open an editor like I did. So all you had to do was go into the specific file, click on that file, and then open that up. So, okay. So now you can just type in this, right? But you might be thinking that in my env file, I had not created the IP address, right? So that is what we are going to do next. So you can make changes here, click on Control Save, and then just close this. And you can see that my .env file is not present here. So what we have to do is go to Find Files, click on, type in .env, and it would show that there's a .env file. Click on Edit. Now what you have to do is write the IP address is equal to the IP that was showcased in your virtual machine here, right here. So that is what you have to have in your IP address here. Okay, so once you have saved this, made changes and saved this also, close this, again close this, then you have your things set up here too. Then if you want, you can close this. If you want to have it open, you can keep this open. But know that there's gonna be a specific time frame till which this can be open and still remain idle. After that, it would close the connection by itself. Okay. Now you have your code, you have your stuff, right? So the last thing is to set up the code inside your VM, right? So we would be doing that in the next video because that has some set of commands that you need to know about, how to use them, and finally run the server. But before ending this video, I'm going to talk about one last thing, okay? That is, go back to your dashboard, and in the dashboard, click on VPC settings, go to firewall. So I talked about inbound and outbound rules. Okay, maybe I didn't talk about inbound and outbound rules, but I talked about security groups and firewalls, right? So here we have to write some rules so that our application is able to access, or our virtual machine is able to access the application. Okay. So I'm going to talk about the inbound and outbound rules. Now, a security group acts as a virtual firewall for your Google Cloud instance, right? To control the incoming and outgoing traffic, which is our firewall right here. So this is a list of rules that will allow control for incoming and outgoing traffic. Now, inbound rules over incoming traffic to your instance, and outbound rules control the outgoing traffic from your instance. This might not have made things clear what inbound and outbound rules are. So basically, inbound means incoming connections coming to your Google Cloud instance from anywhere across the internet or anywhere across other platforms. And outbound means outgoing connections from your Google Cloud instance, which means to connect to the internet or any browser through your instance. So those are the outbound or outgoing connections. So we specify them here, and you need to create a new firewall rule, right? You need to do that, and there you will see some things like name, description, and other information. But you just have to type in the name. Let's say I'm typing it allow Django 2, right? Then I'm giving the description that something, something, something. Then let things stay as it is, but in the source IPv4, you would see that it is giving you some examples too, right? So you have to choose the 0.0.0.0/0, right, for setting it as all rules, and then you need to go to the specific protocols, input the TCP and port 8000, because that is what Django is working on or needs the connection on this particular port. Then you can just create the rule here. So I'm going to go cancel this because I've already created one. So once you click on create, it would showcase the Django, allow Django, the name of your firewall, targets, and then the IP, then the protocol and the port. So this is the most important thing. Okay, so don't mess this up, and even don't mess this up, right? The source IPv4 range. The rest you can make changes or leave it as default. Now coming back to your VM. Okay, coming back to the VM. Right. So the only thing left is to set up things inside the virtual machine, which I'm gonna go forward in the next video. So see you in the next video. Hi guys. So we left off where we were starting to, get into the VM and then set up things like installing the pip, installing our requirements, right? That might be needed by the project and all. So we're gonna do that in this video. It is a small process, right? And with this completed and running, you would be able to access your project. I would say access your website from anywhere across the internet, and through that you can, input the data and see if your model is working as it should or not. Right? So I have my VM, which is the ad classification. You might have your VM with you, and then in that you would see there's a connect option, right? So just remember the external IP. And one thing to note here is that if you, let's say, in your more actions, delete it, reset it, stop it. Okay, it isn't giving you the option of stopping. But if you have used some other instance which has the option of stop, then each time you stop and restart or just restart the VM, the thing is your external IP will change, because what happens is that Google Cloud dynamically provides you these IPs, and these IPs changes uh, whenever you start or whenever you restart your instance. So now click on this, open in browser. Okay, so unless you don't want to do that, you can either go for use another SSH client and use the putty that we were, that I told you to install. Now, if you haven't installed that, then you can just use the browser version there. Okay. Yeah, so it will show you it's connecting and establishing an SSH connection, which is basically using the key which we had, input in the when we were going forward with VM creation, right? VM instance creation, not VM creation. We're not making any hardware here. So once you open this up, you would get the ID of the Google Cloud, right? Your Gmail ID, and then your name of the instance. So while this is all good and fine, but the thing is we didn't create the SSH key for the Gmail ID. We created the SSH key for the local user, right? So if you see, if I type in a command that is ls-a, you can see there's a dot bash, there's a dot bash logout, bash history, there's the bash rh and cache and a lot of things, right? So what you have to do is you have to actually get outside this directory into the home directory, right? So outside this directory is the home directory. Now I'm the root, and then type in the same command, you can see now there's three folders right here inside the home. One is loose leaf. Okay, this was actually my ID that you can even see here. Then there's kit, which was my local instance user, right? Okay, my machine user, basically my laptop has the user named kit. Then there's a Ubuntu. If you go into this and start making changes, then you would be doing things as a root user. For now, we are just going to go forward with your kit, or I mean your username, right? And that is because the SSH was provided for only this. Then cd into kit -a. So if you do this, you would again see that you have your my site folder here, which we transferred from a local machine to the virtual machine through WinSCP, right? Now, ls-a is the command to showcase all the files and subdirectories inside a particular directory, right? Dash a is the flag to show everything. Then we have a command that is nano, right? So let's say that I want to make some changes in a particular file, which you have closed the WinSCP and you now want to change things, right? So what you can do is let's say that I want to change the requirements.txt file. Okay, I want to make some changes there. So what I would do is I would write the command nano requirements.txt. So this will open up an editor for me, and here you can see that I have a lot of uh, things written here. Let's say that I have to make some changes here. So I made some changes here. Then I would type Control X. It would ask me if you want to save the modified buffer. I would say yes. Then if it would ask me if I have to save the file with the same name, I would click enter, and then this gives me an error, that is error writing requirement.txt permission is denied. Okay, so you can see that with the nano we got our editor to open a particular file where we can make changes, but we were not able to do so because we don't have the rights for it. So to override the rights, you can use the command sudo, which gives you exactly the administrative rights, and with that you can make changes, you can append things, delete things where you were not getting the permission before. So sudo nano. So we just precede the any of our commands with sudo. Then I would write requirements.txt, and let's say that I want to make changes, right? I made some changes. Assume I made some changes, and then you go forward and see you can make the you were able to make the changes right now. So this is the sudo command. Then we have a free dash m. So this will show you the free memory, right? It would show you the total memory, then the used one and the free one, with lastly the available one, right? Now it will also show you the swaps too, but this instance doesn't have the swap structure. Then we have the df dash h. Again, these dash a, dash h, dash m are flags which are additional commands on top of these ones to tell what is happening, right? What exactly I want to have. So you can see with the df-h, I can see the size of my root, how much has been used, what is available, and for other uh, parts of the disk too. Then moving forward, so we have our manage.py file right here, right? So you run the command. Okay, even before this, you have to run a particular command that is right here. So you can take a SS for this. So I have the steps to instantiate your VM, to setting up your VM and finally running the VM, right, and the code in it. So this is for your app engine. This is for Azure. So if you want to use Azure, you can go forward with this too, right? Now the command to run is this one. So this command actually updates. So it either updates or it downloads it. Okay, so run this command here. Now I already have this command with me, right? So I've already run this command, so I would get no updates. So I'm gonna skip this part, but you have to run this command because this is the most important command when we are talking about installing our dependencies. Here it's either asking to either update, or if there is no pip installed already, then install the pip3 for Python 3.xx versions. Okay, so that is for that. Then once you have run this command, it would in between ask you for permissions. So you just have to type in Y and click enter, and then it would install everything that is needed for pip to install other dependencies. So once that has been completed, you would run the command pip3 install -r requirements.txt to install all your dependencies, right? So the thing is why I didn't run the previous command is because it is also going to take some time to install each and everything that is required. Okay, so it might take some time from around 2 to 3 minutes to 10 to 15 minutes. Okay, so keep that in mind. Then we run this command to install our dependencies, and you can see that I have all of these getting installed, right? So you can see I'm installing each and every one of the dependencies right here. Now TensorFlow is a big library, so it is going to take some time to load and install, right? Then yeah, you can see that it is 172.4 MB in size, so it is taking time. Right, so this would take some time again for you, depends on person to person. Sometimes it is processed pretty fast, sometimes it takes a lot of time to do so, right? Then, okay, yeah, so you can see that I'm getting some warnings, right, about the path. So this is happening because we have directly installed the versions. We haven't installed, or we haven't created a virtual environment inside the VM and then installed it. So this would give me some of these errors right here. Okay, so if you want, you can with the help of virtual env create a virtual environment, then start the process of installing all the dependencies. But since I'm gonna just finish the project here, I'm not going to make any changes or work upon this again. So I'm just installing all the dependencies directly in the root, right? So this again will take some time, and once this is done, we can say that yeah, every dependency that your code might have has been finished or completed. And lastly, we would move forward with the specific Django commands to set up the okay yeah to set up the site. Now you run the command python 3 -py migrate, and if there's no migrations to apply, it would tell you yeah, no migrations to apply here. If okay, then we run the last command to start our server, which is run server, that is on this and port 8000. So you run this, and after system checks, it would see, and it has provided you the URL here. So again, go back to the instance dashboard, copy your external IP address, click okay, and here okay, just hit enter, and it would show you it was not able to connect, or yeah, you would get this error, and I will tell you why. Because okay, why exactly? Okay, that is happening because you have to type in http:// and it has to run on port 8000/home. Right, once you hit this, you would see that your page is now loaded. So the thing is, first you have to run the external IP with the HTTP, not S, because we haven't used the secure one. You have to set up additional things with your VM and the network to do that. Then on the home path, we will have our site ready here. So if I type in, okay, there's nothing to type in, but yeah, let's just create something, and then so the thing is, you can see that I have typed in something which doesn't exactly belong to any of the categories. So I'm a little curious too as to what this would get me. Okay, it's getting me food, which is close because we're talking about medicine and eating that, right? So it is getting me food, which is fine. So with this, we have completed our third part, which was the last part, hosting our website, right? And with this, you can, on this particular link, access your website and run your project from anywhere, right? So I hope you liked this project.